Hey guys, we are going to do the biconditional foldable. So you have a front and then you have kind of like two backs from that. So get the sheet that looks like this. So a biconditional statement is when a conditional statement and its converse are both true, then we can write the two together as a biconditional statement. Okay, but we have to have both the conditional statement and the converse to be true in order to write it as a biconditional statement. Okay, and remember, the converse of a statement is if Q, then P, so we're flipping the hypothesis and the conclusion of the conditional statement. So an example of when we could write a biconditional statement would be if these are our two declarative sentences, one here and one here. So it says if B is between A and C, so let's just draw a visual. A, C, and B is between it. So if B is between A and C, then AB plus BC equals AC. Okay, that is a true statement. That is the segment addition postulate, but that is in fact a true statement. All right, now if we look at this one here, it says if AB plus BC equals AC, then B has to be between A and C, which is also a true statement. So this is true and this is true. Now, because both the conditional statement and the converse are true, we can write this as a biconditional statement. So biconditional statement is not an if-then statement. Okay, it's not if-then. Okay, we can write this as an if and only if. Now sometimes, guys, if and only if, sometimes this is abbreviated as IFF. So if you see IFF in a math class, it just means if and only if. So if we're going to put these two together and write it as a biconditional statement, I would say B is between A and C if and only if, here's our key right here, if and only if, AB plus BC equals AC. All right, so if we fold that page over that we just did and we fold it in half like it's a book, that's how we'll fold this and glue it into our interactive student notebook. So kind of the inside of this flap, when we turn it over, you see this page here. So it says, whenever a theorem is investigated or proved in geometry, the converse is also examined. When both the theorem and the converse are true, we can write it as a biconditional statement, which we already put on the page before. Okay, so when we write biconditional statement, it is two conditionals that are converses of each other. Remember, the converse and the conditional has to be true. All right, so here's an example. This is a biconditional statement. And the reason we know it's a biconditional statement, notice it doesn't have an if and it doesn't have a then. It has an if and only if in the middle. Okay, so let's look at this a little bit closer. Okay, so my conditional statement, remember a biconditional is a conditional statement and its converse both put together, but both the conditional and the converse have to be true. So let's look at the conditional and converse of this. It says a number is divisible by 3 if and only if its digits is divisible by 3. All right, so I can write the conditional statement as if it is divisible by 3, comma, then, because remember a conditional is an if-then statement, then the sum of its digits is divisible by 3. Okay, if it is divisible by 3, then the sum of its digits is divisible by 3. That is a true statement. Okay, now if we write the converse of that, okay, The converse of that, remember, we're flipping the hypothesis and the conclusion. So if the sum of its digits is divisible by 3, then the number is divisible by 3. Okay, so if the sum of its digits is divisible by 3, then the number is also divisible by 3. This is also a true statement. Now, because the conditional and the converse are both true, that's the reason we can write this biconditional statement. If one or both of these was false, we cannot write it as a biconditional statement. All right, here's the last part of this biconditional is foldable. It talks a little bit about good definitions. So a good definition is a statement that can help you identify or classify an object. A good definition has several important components. The reason we're bringing definitions is because definitions, or maybe I should say good definitions, can always, and remember, these have to be good definitions, can always be written as a biconditional statement. Okay, so now what constitutes a good definition? Well, first, we have to use clearly understood terms. Okay, so we're not using vague terms here. We're using very exact, clearly understood terms. Leave nothing for the imagination. We also are using precise words. Okay, we avoid words such as large, sort of, almost. Okay, those are kind of vague words. We want to be very precise and very intentional with our word choice. Okay, last but not least, good definitions are reversible. It can be written as a biconditional. All right, below that you should have some room. So what I'd like to do is write an example in this. So we're going to write the example or the definition of perpendicular. Okay, so perpendicular, this is the symbol for perpendicular. So perpendicular lines are two lines that intersect to form a right angle. Okay, that's the definition of perpendicular lines. All right, so if we break this down, the converse, now let's do the conditional first, just stay in the same order we always do. Let's do the conditional statement first. Okay, so the conditional statement would be if two lines are perpendicular, then they intersect to form a right angle. If two lines are perpendicular, then they intersect to form a right angle. That is a true statement. All right, now let's write the converse of that. Okay, so remember the converse, we're just switching the hypothesis and the conclusion. So if they intersect to form a right angle, then the two lines are perpendicular. Okay, now if you notice, both of these statements are true. So take your time, read through them, notice they're true, and because they're both true, I can write them as a biconditional. Okay, which would be two lines are perpendicular if and only if, and here are my keywords right here, if and only if, they intersect to form a right angle. Okay, so that's just an example. Conditional converse have to both be true, and then you could write it as a biconditional.